Okay, we're doing Algebra 1, the first section in Chapter 6, and this section is all about properties of exponents. So you'll have noticed that these properties are also up on my one of my bulletin boards, and you're going to have to remember these properties. The best bet would be for you to memorize them and know how they work. Okay, so the first one is the zero exponent. And you need to know the rule for this is anything to the zero power is equal to 1. I'll show you why this works in class. But for right now, you're just going to write down for your notes all of the properties of exponents. The negative exponent rule is if there's a negative exponent, you take the reciprocal of the base. This part is the base. The reciprocal of x is 1 over x, and then the exponent becomes positive. Product of powers. Product, remember, means to multiply. If you're multiplying same bases, you add the exponents. And if you think about what this really means, x squared is x times x, and x cubed is x times x times x. Well, if you count them up, there's 5 of them. So you add the exponents. The quotient of powers. Let's look at what this means. It means x times itself 5 times on the top, x times itself 3 times on the bottom. Well, I can take 3 away from the top and end up with x squared. So really what I've done is I've taken the top exponent and subtracted the bottom one. So subtraction goes with division, adding goes with multiplying. And then the power of a power rule, let's remember what this means. X squared means x squared. To the third power means you do it 3 times. And if we count up all those x's, we get x to the 6th, which is equal to x times the 2 times 3. So you multiply the exponents when you're raising a power to another power. The power of a product rule, if you have 2 things multiplied together in parentheses squared, it squares both things in parentheses. Remember, if the exponent is outside of the parentheses, it applies to every term in parentheses. So let's say we had 2x squared. The 2 gets the squared, so does the x, and I know what 2 squared is. Okay. The power of a quotient, same thing applies. Anything in parentheses gets this exponent. So let's say we had x over 3 squared. That's going to be x squared over 3 squared, which equals x squared over 9. All right, let's go ahead and do some of the examples from your worksheets. I'm going to go ahead and start with number 5. Okay, so remember this is a anything to the 0 power is equal to 1. And since I'm going to be dividing by 1, it doesn't really matter. I can just write it like that. So now I have a negative exponent. Let me get that arrow out of the way. Sorry about that. So when you have a negative exponent, you take the reciprocal of the base, which is 1/3. The exponent becomes positive. So this would be 1 over 3 squared, which is 1 over 9. Next up is number 12. I'm gonna just do a couple of steps of simplification. I know that anything to the 0 power is equal to 1, so I don't even have to write that. And then I have t u to the negative 5th. But I know what 2 to the 5th is. 2 times itself 5 times is equal to 32. And now I have this negative exponent, right? So when you already have a fraction set up and something up here has a negative exponent, then I know I have to bring it down. I have to trade places, and then the exponent becomes positive. If that negative exponent was down here, then I would have to move it up. So this would be t stays on top, and then 32 and u to the fifth has to come down because it's a negative exponent. And that's all I can do with that. Okay, so remember what we do when we multiply. We add the exponents. Negative 4 plus 4 is 0, and anything to the 0 power is equal to 1. And let's do number 23. So there's a lot of different ways I can do this. I can simplify everything in here first and then apply the exponent, or I can go ahead and apply the exponent to everything right now. I think what I'm going to do is simplify the inside first. Okay, so 3 and 2 don't have any common, I mean, they're both prime numbers, so I'm just going to go ahead and repeat those. So now let's look at the x's. Remember what I said, if the exponent's negative, it has to move up. So it would have to come up and join this one, and the exponent becomes positive. So that would be 2 plus 3, that would be x to the fifth, and it's going to be up on the top. This one's negative, so it has to come down. And then that would make y squared times y to the third, which is y to the fifth. So now I've simplified everything I can on the inside of parentheses, and now I'm going to apply the exponents to every term in there. So this would be 3 to the third, x to the 5 times 3. The bottom would be 2 to the third, y to the 5 times 3. That also is 15. 3 to the third is 27. 2 to the third is 8. And that's as far as I can go. So when you're simplifying things with exponents that look like this, it's like peeling an onion. You just do one simplification step at a time, and don't skip steps. Don't do things in your head. Write down everything. Yeah, I can't stress enough that you got to write down everything. There's also some scientific notation problems on this worksheet, and I just want to remind you what scientific notation is. So the form is always there's always only one digit to the left of the decimal. Everything else is written after the decimal. So if I'm 1.4 times 10 to the 6 means that if I go from the decimal in the number to the decimal right here, which would be right here, look at how many times I have to move it. 1, 2, 3, 4, 5, 6. So that's why it's 10 to the 6. So if you write down the 1, put down the 1, and then you put, and then this, and then there's 5 zeros, because everything after the 1 has to be 6 digits. 1, 2, 3, 4, 5, 6. And then remember, times 10 to the negative exponent, that means that this is a really small number. If the exponent for 10 is positive, then we know it's a large number. If it's negative, it's a small number. And scientific notation is used a lot in science because you're dealing with really, really large numbers and teeny, teeny, tiny numbers. So that's why they use scientific notation with that. So this one, since I know it's a decimal, so I'm going to put my decimal, and then I count 1, 2, 3. On the fourth spot is this number right here. Because look at how many times I have to move the decimal from here to where it appears right here. 1, 2, 3, 4. And that's just a quick down and dirty reminder of scientific notation. And all of the exponent rules apply to scientific notation. We just do it a little bit differently. So number 26 is a division problem. And if you're multiplying or dividing with scientific notation, you're going to divide the number part right here, 3.9 divided by 1.3. And then you're going to set that separately. Well, I know that the quotient rule tells me that I subtract the bottom exponent from the top. So that would be 10 to the 5th. And 3.9 divided by 1.3 is 3. I guess to be really appropriate, you would say 3.0 times 10 to the 5th. And that is it for 6.1.